Hello everybody, I'm Gleb and this is my 5G course on IoT Understanding channel. As for today, we're going to continue to talk about 5G beamforming technology. We've already know that previous generations networks and actually 5G are facing some challenges, some problems, and beamforming helps to tackle that problems. Is a good solution to consider mobile networks from cell-oriented, from sector-oriented networks to beam-oriented networks. This is a completely game-changing solution. So, in this video, we're going to talk about how beamforming can be formed, in what different ways, what's the difference between them, and we're going to talk about how it works in 5G, how beam can be managed in 5G system during initial access or in RC connected mode state. So we have different types of beamforming. We can have analog beamforming, is when digital signal after baseband processing is converted to analog system and then actually amplified, that signal amplified in analog form. Here we can draw an amplifier. Yeah, let's suppose this is a radio remote unit with amplifier. That signal amplifies and goes to antenna with multiple antenna elements, with a number of antenna elements. Inside that antenna, we have phase shifters that can change phase of multiple signals and to adjust the whole antenna system to narrow the particular beam for the necessary direction with necessary characteristics. So this is analog form, so any changes is done in analog form. This is a very cost-effective solution, and probably no hardware changes you've got to have in digital form. Only changes in analog form, inside antenna, inside huge antenna array. When it comes to digital beamforming, we have a baseband processing. Inside baseband, in a digital form of signals, we can change phase, and we can even change amplitude and somehow change subcarriers in terms of amplitude, of course, in order to suppress the side lobes in a diagram of such antenna. So this is an advantage of digital beamforming. So all of these changes is in digital form. Then we converted signal from digital to analog. Then we amplify that signal by power amplifiers, and such signal goes to antenna with multiple elements. So in case of analog beamforming, we can handle and use only one beam, and this one beam is formed actually only by, it doesn't matter actually how many antenna elements you have, but all of these antenna elements is participant in that one beam handling. When it comes to digital beamforming, you can have different numbers of beams, and this number of beams is maybe equal to number of antenna elements. So you can have a number of beams, actually number of signal sources. This is more advanced system, but of course such system is extremely it is cost extremely so this is a disadvantage of that. It is a very complex system, and I suppose that one of the common solution for that has a hybrid form of beamforming. It is probably something between analog and digital beamforming. Is when something may be done in analog forms and some changes may be done in digital form inside baseband unit. And now we find out how beamforming technology works actually. But let's find out how it works in 5G during the different procedures. So in 5G NR, in order to perform such procedures as initial access or beam management, the user equipment and the network has to be able to do somehow such procedures as beam searching. The UE has to know how to find beam, how to filter measurement results in a specific way for particular beams, to perform acquisition of beam and getting access to network. The UE has to know how to track this beam due to the UE is a mobile device, and there is maybe some movements, so the system should know how to track the UE, and the UE should know it in that way, collecting some feedbacks and send to the network. Calibration, because the radio environment and the propagation is changed, and the UE is moved in every possible direction. So the calibration is a very important procedure. If it's necessary, the UE has to know how to switch to another beam to make switching between beams. And in case of beam failure, the UE has to perform beam recovery procedure. So this procedure is performed via random access procedure. So as you can see, there is lots of different procedures for initial access, for beam management, and of course such transmission I suppose have lots of overheads, but let's look at the physical layer, how it works on the physical layer during initial access, for example. So on the physical layer, instead of just transmitting the broadcast information in one sector antenna, as it used to be in previous generations, as it with usual panel antennas. So instead of broadcasting in a wide direction, in 5G beamforming, such signals as primary synchronization signal, secondary synchronization signal, physical broadcast channel is formed into one synchronization signal block, and such blocks are formed into one SS burst, synchronization signal burst. Such SS burst may have just one, or multiple SSB blocks. Yeah, such burst organized in a burst set. So this is the way how it organized in terms of synchronization signal blocks and in terms of broadcasting system information. So for every such SSB, we have a particular, it's supposed to have a particular beam. So in this case, for the UE, SSB is a particular beam. In the case of initial access procedures. Actually, if you want to know more about initial access in 5G and what's the fundamental difference between 4G and 5G in terms of initial access, there will be soon my new video about that topic, and I will put a link in this corner so you can find this video here. So this is how it organized on physical layer. One SS block contains one symbol PSS, one symbol SSS, and two symbols of physical broadcast channel. So let's look on other side how beam management works and what it contains. So every SSB block has its own beam. So and the number of beams depends on the frequency we use for transmission and reception. 4 beams maximum is allowed for low bands, particularly is up to 3 gigahertz. 8 beams maximum for mid bands, as we call it, mid bands, or we call it C band sometimes. This is a range from 3 to 6 gigahertz frequencies, and maximum 64 beams for millimeter waves, for high bands, as we call it again. And actually it starts from 6 to 52.6 gigahertz. So this is a part of FR2 and part of FR1, as you can see. And actually FR2 bands, in particular 5G TDD mode, time division duplex mode, is more preferable for using beamforming, because in a downlink direction and in uplink direction is used the same frequency. The signal transmits and received on the same frequency, the separation only in time. And this is very good for beamforming, for estimating the channel, because the channel on the same frequency. So let's look at the beam management procedures. Well, in 5G NR, for beam management, we have different procedures. First of all is measurements. The UE, when detecting and finding appropriate beam, is sending measurement reports about that, about quality of signal of that beam. Then we have a beam detection and identification. Actually, it goes first. Beam recovery. It goes via random access contention-free based. Actual for FR2 for millimeter waves. Beam switching is only for RC connected mode, and beam sweeping. This is a little bit confuse things between beam switching and beam sweeping. beam switching is only in connected mode. Beam sweeping is when we have initial access to the network, and the UE send random access preamble to network using one beam, and if it fails, if it was a failed attempt, the UE may sweep to another beam, choose another beam for sending in uplink random access preamble. So this is a little bit confusing, but again, this is in connected mode, and this is during the initial access procedures. And actually, by doing that, we can gain the probability of fast initial access, even if first attempt was failed. So this was my basic and short video about 5G beamforming and measurements and management and all of these interesting things. If you like this video, if you want to know more about 5G technologies, you can like and subscribe. And if you have any questions, feel free. You can send me to my email. You can send your question in comments below. So feel free, don't hesitate, and stand by with IoT Understanding channel. Goodbye.